This video is about finding and comparing unit rates. So first of all, recall what a ratio is. A ratio is simply a fraction, usually comparing two things. Sometimes you have ratios where you're comparing three or more things actually. But it's simply a fraction, a divided by b, or a over b, which is a divided by b, which is a to b. These are all represent the same things, just different ways of representing them. B cannot be 0 because you cannot have division by 0. So for example, a class contains 30 students. 18 of the students are boys. Write in lowest terms the ratio of boys to girls. Well, if there's 18 boys and 30 students, that means there would be 12 girls. So the ratio of boys to girls would be number of boys to number of girls, and that would be 18 to 12, which we can reduce because we can divide 6 into both 18 and 12. 6 is canceled, so that's 3 to 2. You could also write this 3 to 2 this way, or 3 to 2. Then the ratio of girls to total students, well, there's 12 girls, there's 30 students, so that's 12 to 30. So the number of girls to number of students is 12 to 30. Well, 6 also divides into both of these. So this becomes 2/5, or 2 to 5. So the ratio of girls to total students is 2 to 5. So now, what is a rate? A rate is a ratio that compares two different quantities with different units. So for example, 55 miles per hour is a rate where you're describing in 1 hour you go 55 miles. So a unit rate, and we could actually put a 1 here, because in the case of a unit rate, the denominator is always going to be 1. So 100 gallons per minute is a unit rate. 32 miles per gallon is a unit rate. In this case, this is in 1 minute. This means, so you can also interpret this as 1 minute. So this is 100 gallons per 1 minute. Now I don't know that still doesn't tell us what actually is doing this, but that would say in 1 minute's time, 100 gallons, say it's 100 gallons flowing through a pipe. That would be a unit rate. This could be a gas mileage here, 32 miles per 1 gallon. So for every gallon of fuel, say a car gets 32 miles. And then say you have 5 pounds of, let's just say you have steak. So let's say steak is $5 for every 1 pound. These are all unit rates because the denominator, they are ratios, but the denominator has a value of 1. So again, what is a unit rate? A unit rate is a rate where the denominator of the fraction is equal to 1. So for example, write as a unit rate. You travel 200 miles in 4 hours. So what you do is you write it as a fraction, 200 miles per 4 hours. And the fraction bar, which also means division, we say per, the word per. So it's 200 miles per 4 hours. To make it a unit rate now, I divide 4 into 200. Well, this is simple enough that I don't need a calculator. That's going to be 50. So this is 50 miles per 1 hour, or 50 miles per hour. Now on a highway, you would see this represented as 50 mph. But this is the mathematical scientific way of writing it, 50 miles per 1 hour, or you just write 50 miles per hour. So another example, write the unit rate, round to nearest cent. 5 pounds of hamburger costs $7.30. Give the rate as dollars per pound. So I spend $7.37 for 5 pounds. So now I'm going to take my calculator and I'm going to divide 7.37 divided by 5, and I get 1 point, let's copy that. Four didn't show up there. This should be 1474. So this is $1.474 per pound. That's the unit rate. Now money, American money, we express to the nearest cent. So that's a 4 behind that 7, so the 7 stays the same. So this is $1.47 per pound. And this is how you can do comparison shopping when you put things in terms of unit rates. So using unit rates to make comparisons. A primary use of unit rates is to make comparisons between two or more ratios. So for example, a car travels 5,875 miles and uses 250 gallons of fuel. So that's a first car. A second car travels 3,540 miles and uses 150 gallons of fuel. Which car has the better gas mileage, miles per gallon? So we're going for the first car, we'll call it car 1. We get 5,875 miles on 250 gallons. In car 2, we get 3,540 miles on 150 gallons. So to get the unit rate, we divide the numerator by the denominator. Let me use the calculator here. So I have 5,875 divided by 250. And I get 23.5 miles per gallon. So this is 23.5 miles per gallon. The second car, I get 3,540 miles on 150 gallons. So I divide 3,540 divided by 150, and I get 23.6. So this is 23.6 miles per gallon. Since 23.6, if you want to compare 23.6 to 23.5, you can line up the decimal points and go digit by digit. They're equal here, but this 6 is bigger than this 5, so 23.6 is greater than 23.5. So car 2 gets better gas mileage. Okay, second example. One runner covers 89.96 feet in 5 seconds. A second runner covers 101.4 feet in 6 seconds. Which runner is going faster? So runner 1, what we want is, we want feet per second here. So notice we have feet here and seconds here. So I'm going to write for runner 1, he or she goes 89.96 feet per second. I'll let S represent seconds, and that's 5 seconds. Runner 2 goes 101.4 feet in 6 seconds. Now you could divide 5 into 89.96, but I'm going to use a calculator here. So I have 89.96 divided by 5. We get 17.992 feet per second. So these are my units, feet per second. So now on the second runner, I take 101.4 divided by 6, and I get 16.9 feet per second. So in this case, think it's pretty obvious that runner 1 is going faster based on our information because he or she is going further. 17.992 feet is greater than 16.9 feet. So runner 1 is going faster. (17.992 feet per second is greater than 16.9 feet per second. Okay, using unit rates to make comparisons. Well, actually, that's what we just did in the previous two examples. So here's an example of which is a better buy. 20 ounces of a drink that costs $1.56 or 26 ounces of the same drink that costs $2.04. So we'll have the 20-ounce scenario first. So we want to find a unit cost, in other words, which is dollars per ounce for each amount. So we can, for $1.56, we get 20 ounces. And that's gonna put us in terms of dollars per ounce. And then for the 26 ounces, we have $2.04 for 26 ounces. Now I simply take my calculator and take 1.56 divided by 20, which gives me $0.078 per ounce. And then for the other example, I take $2.04 divided by 26, okay. Now that's, I'm going to carry this out a little bit. That's 0.078. I just need to go one more place. That's a 4 there, but that's a 6 behind it. So if I round that 4, since that's a 6 behind it, becomes a 5. So this is $0.0785 per ounce. And then if you want to compare the two numbers, what I can do is here I can add a 0, and since 0.0780 is less than 0.0785, we know that the first drink, the 20-ounce drink, is cheaper per ounce, or is a better buy, since $0.078 per ounce is less than $0.0785 per ounce. Now when you're comparing unit prices, you don't always have to round to the nearest cent. So here, if we round to, well, if we round this to the nearest cent, this actually would become 0.079 because this 5 makes this 8 and 9. So the 20-ounce drink, the bottom line is a 20-ounce drink is cheaper per ounce. And this concludes the introductory video on unit rates.